thank you everyone for coming today. Today we're going to be doing a little demonstration and workshop regarding Polaris, which is the EVM framework that we've created in order to get all the EVM goodness on Berachain. For a little bit of context, Berachain is the EVM compatible L1 built using the Cosmos SDK. We replaced kind of the traditional proof of stake model with something we call proof of liquidity, which incentivizes validators and node operators to provide liquidity as part of securing the network. And as part of this, we felt that EVM compatibility was something that was really important to us. The background of kind of my co-founders and a large part of the core team was from the EVM ecosystem. And despite liking Cosmos, we love Cosmos, but we really wanted to make sure that our friends and builders in that ecosystem were able to participate in our chain. And felt that we wanted to provide them an EVM experience that was equivalent and made sense. So that's how we ended up where we are today. Along that journey, we became really good friends with the guys over at Celestia. Huge fan. Again, appreciate them for running this conference and everything they do for us. Diego and I have spent a lot of time getting not only Polaris working, but Polaris working with Rollkit and some other EVM frameworks as well. So that's what we're going to be demoing today, is showing how you can build your own Polaris chain, which is, again, Cosmos, fully EVM equivalent, but have it post data to Celestia's DA.
Yep. Everyone, hi. I'm Diego. I work at Celestia Labs. I do a lot of stuff with Rollkit, but also with other frameworks. And like he mentioned, we worked together on, multiple times on integrating Polaris, which is a Cosmos SDK like EVM library, and Rollkit, which is a drop-in replacement for Tendermint. That allows us to take their software and combine it with ours to make EVM rollups on top of Celestia.
So to give a little overview of kind of the architecture of what we're going to be doing today, or part of the architecture of what we're going to be doing today, is that as part of kind of the test of ensuring that Polaris was a fully EVM equivalent chain, the RPC was working correctly, all the opcodes and everything were working correctly, we thought that if we can deploy an OP stack rollup that settles on a Polaris chain, that's a really good kind of real world test to make sure that are all the RPCs responding correctly? Is everything working? Can contracts deploy? Can hard hat deploy work? Can Foundry deploy work? All these things. So we were fortunately able to do that, and not only were we able to do that on a Polaris chain that's operating as an L1, but in addition, one that's actually settling on Celestia as well, utilizing Rollkit. So if we go over to, where's Chrome here? Oh, it's here. Perfect. So if you guys want to go over to github.com/Berachain/Polaris, you'll see this is our core repo. So it contains a wide variety of packages regarding, or a wide variety of modules, I should say, that are used in order to make up kind of the core Polaris framework. One of the core distinctions that we made as part of this was we really wanted to bifurcate all of the things that are happening in the Cosmos runtime versus things that are happening in the EVM runtime. So what we did is we have like an actual full kind of ETH module that has all of our common Ethereum logic. So this is kind of what's interacting with the state machine. This is handling all of kind of the RPCs, just all of the state processing, et cetera. And then our actual Cosmos side of things really just is a communication layer that allows the Cosmos client to communicate with the ETH client. And that's a big part of what allowed us to get that like true raw EVM compatibility, is we weren't reinventing the wheel. We weren't trying to take Tendermint RPCs or take something about Cosmos and make it look like Ethereum. We were like, okay, how do we take Ethereum and make it so that Cosmos can communicate with it? So secondly, if you go to here, so go to Berachain/Modular. So it's Modular Summit Workshop 2023 with all the dashes and stuff. So this is basically what we're going to be doing today. So the first thing we're going to do is we're going to spin up a local Celestia DevNet. Then from there, we're going to configure the Polaris repo to be able to post to that DevNet that we're running. And then basically we can go from there. We can make sure we have Foundry installed in order to deploy contracts, do the setup, et cetera. And then we can start the chain and start to interact with it like any other EVM chain. So if we look over here, basically we have Polaris repo here. What you want to do is you want to check out this specific Rollkit branch. If you go on Twitter and see any memes or know Scott Sonardo, you'll know that Diego works tirelessly and effortlessly every night putting together new Rollkit branches.
Yeah, Chief Branch Officer.
Chief Branch Officer. Fortunately, though, due to some creativity, we'll say, setting up a Polaris chain to utilize Rollkit over in lieu of comment or tenement. It's pretty simple. Right now, all you have to do is just you have to do a simple replace statement of the SDK just to get the Rollkit compatibility, and then this proto buff replace that if you've been in Cosmos for a very long time, you will know how much we love this this replace here. One day we'll get rid of this in the Rollkit version, but for now, for now it's here. So yeah, kind of going back and following our instructions here. You know, if you just copy this guy here, you'll be able to spin up the local Celestia DA. Should boot up. Takes usually a minute or so. Now, once this boots up, the one thing we'll have to do is we'll have to copy this authentication key. This auth key is basically to prevent anyone who isn't you from basically spamming your full node or light client. But you have to copy it over, which is something that we discovered setting this up can be a bit of a cumbersome process. So we'll be the Rollkit guys will hopefully be sorting that one out soon. But soon, coming soon. But there should be an auth token that comes up here, right? So you'll see this little message here, and then you'll get this big auth token guy here. If you go back into Polaris here and go into just this basic init script, all you have to do is scroll down to the bottom. This is probably really small, I just realized. You just need to go down to the bottom here, and basically there's this auth token place. You'll just want to go replace this guy here.
And this is just for the workshop. Usually if you were running this on a testnet or live, you wouldn't, it wouldn't print the auth token. You would have to get it from a file.
Once that's set up, we can just run mage start. For anyone who doesn't know mage, it's like a really cool alternative to make files that allows you to write your logic in actual Go scripts. So it's kind of nice for doing complex things. And we give it a second here, and it should start producing blocks. Validation ignored, but Diego assures us that's okay. It's supposed to do that.
That should be a warning. It'll get fixed in the next branch release next week.
Good. So we should give it a second here. I've been assured by Diego that this works, so if it doesn't work, it's
Dude, we ran it 5 hours ago.
So there we go. We can see that we've successfully submitted a Rollkit block to the DA layer, which is super awesome. And then from there we have a fully EVM compatible chain, right? So we can go and we can in the Polaris repo there's some example contracts. So if we go into where's an example here? If we go into source, what do we got? Maybe some testing contracts. So consume gas is one of the contracts we have. So we could do a quick forge create consume gas. And then if we look over here, we have a few private keys and stuff that are funded. So we can do forge create, consume gas, and then what else do we need to do here? I guess we got to go back a couple here. Oops, we could do forge create, consume gas, and then we could do -- private key equals this, and then you could do -- RPC URL, and this is just going to be your traditional localhost 8545 that anyone in the Ethereum community is familiar with. Give that a second, or in the case of this guy, maybe a few seconds. So maybe Diego, if you want to elaborate on some of the updates that are coming that'll allow the block time to be a little shorter.
So currently Rollkit is set to make blocks no more faster than the underlying L1 or the A layer. So in the current local devnet, the Celestia container is going at 15 seconds per block, which means that Rollkit can not safely go faster than that at the moment. However, we are working on this thing called block sync, which essentially allows Rollkit to give users soft confirmations, meaning next time we run something like this, it would be very fast. It's essentially the same concept behind L2s like Optimism or Arbitrum and how their sequencer gives users a soft confirmation when in reality the finality of those transactions takes longer than a second.
Sweet. So yeah, as you can see now that the block's gone through, we have deployed smart contract. This was a deployer address, deployed to here, etc. We have full cast RPC compatibility, so we can do cast receipt here, right? Cast code, my bad. So cast code, we can see that all the code was deployed. So that's our little consume gas contract. It's just a for loop that I think does hashes or something. We can do cast TX. You can see all all the information about the transaction it went through, the gas price, how much gas it consumed, who the sender was, what block it was included in, and we can do this for the receipts as well. And this just kind of shows like we wanted to make sure that even though it's technically running on, oops, I think I copied it wrong. Yeah, I did. Right, yeah, cast receipt. Here, right, that even though it's running on Cosmos and this is a fully, Cosmos chain, we wanted to make sure that like all the tooling, hard hat, Foundry, all these things work perfect. And again, right, we can do that cast block. We can see here that was our transaction that was included. There was some gas used because we had the transaction in there, et cetera. And yeah, so that's basics, the basics of running a Polaris chain and running it on Rollkit and using the Celestia DA for data availability. So I hope this looked pretty simple, and if anyone has any questions or anything or wants to run through it, we'll be hanging out here for a bit. And yeah, Diego, anything else want to add or?
I don't think so.
Awesome.
We have evidence of the OP stack rollup running on Rollkit, running on Celestia.
And we can show that. You can show that guy as well here.
Yep.
So, so here's actually running. Oops. Here's actually an example of it running all three. So if we kind of step back here, so we can see that we have the DA up and running. Then over here we have the Polaris chain.
Yeah, Polaris Rollkit chain. And soon this video should show the OP stack chain that's running on top of the Polaris chain. There it is. I believe that is the OP batcher, OP node, etc. Essentially showing the architecture of that diagram that we had in the slides. It's not a regular OP stack rollup because it's directly connected to Celestia for DA. Maybe we can show the diagram real quick. So yeah, so that video essentially is proof that we were able to run this sometime before this workshop. But essentially, it was a good test of how good Polaris is at being the EVM. Because if you try and deploy even a regular OP stack rollup on some quote-unquote EVM compatible framework or chain, you're going to find that it doesn't work most of the times. So it was a very pleasant surprise that it works with Polaris, and especially with Rollkit. And yeah, can't wait to see people, I don't know, deploying L3s and L4s and beyond with Polaris and OP stack.
Sweet. Thank you, everyone.
Thank you, thank you.
Any questions? Do a little quick Q&A before we move on.
What's an example of why someone would use this architecture?
Would you use this architecture? Diego, maybe you want to elaborate more on the benefits of breaking up the settlement and the DA for the L3.
I mean, somebody would probably want to do this if, let's say, you already, okay, so let me trace back. Assume there's already a Polaris Rollkit L2 on Celestia, right? And for some reason we see that that's not enough in that single instance, and we want to be able to essentially scale more. We can have L3s on top of this instance. I think realistically it would be more for the purpose of having more dedicated space, maybe the Polaris rollup on top of Celestia is more of a general purpose rollup for people to deploy applications, DeFi stuff, NFTs, etc. But people want to deploy app-specific rollups on top of this general purpose rollup. There's also other benefits, assuming that this OP stack rollup on top of the Polaris rollup is not the only one. You do get some form of, well, not some form. You get very strong guarantees for essentially cross rollup transactions, right? You would have one of the OP stack rollups on top of Polaris, make a transaction to the underlying Polaris Rollkit, and then the other rollup, because it shares the same settlement layer, can read this transaction, and essentially you can have the same benefits that you get from having L2s on Ethereum, right? You get the same form of synchrony guarantees, essentially. And yeah, I guess to finalize, the other reason why we would have this OP stack chain post the transaction routes directly to Celestia instead of putting them to Polaris could be because let's say the block size of the Polaris rollup is not the same size like as the Celestia block, right? Like assume the Celestia block is like, I don't know, like 10 megabytes, and that the Polaris rollup it runs at the same speed as the DA layer, right? And has a maximum size of like 2 megabytes, right? That's like very small. That's a very small amount of data that you have to share with like other people on that same rollup when it will be cheaper to just post it on Celestia directly.
So simply put, LP stack here is a L2 and Polaris is a L1 and Celestia is L1.
Yeah, I mean, like, you know, the nomenclature around L1, L2, L3, and all that stuff gets confusing, to be honest.
No, because Polaris is settlement rollup, right?
Yeah.
Is a sovereign rollup here.
Yeah, it's a sovereign rollup.
It's like the fork choice minus the other.
Correct.
But you could do like faster batching, I suppose.
Yeah.
On the LP stack chain.
Yeah.
It's an optimistic change. I had a question though.
Yeah, absolutely.
As an app developer and you're working with precompiles, do you start thinking from like the Solidity interface perspective or like the Go module perspective? Let's say, like, where does your thought process begin? It's like, oh, like I should first like think about like starting the Go module, or should I think about like what interface I need from the Solidity perspective? Because I never built a precompile, so I'm like curious, like what your thought process in like building the precompiles.
Yeah, it's kind of both, and we can probably I can show some examples as well because I know a topic that a lot of people are interested in. For some of like the standard Cosmos modules that we basically take a Cosmos module and then we build like a precompile interface around it. You sometimes have to kind of juggle both, where it's like, okay, like what's a Solidity interface that makes sense for users, and then also like how do we like adapt or pattern that to a Cosmos module. And we've done a lot of like work into making that developer experience like really clean. And kind of, I guess, unrelated to this talk, but I can show some examples as well. And basically, how it works in Polaris is to first write a precompile, you have to actually go in and you define like a Solidity interface here. So like we'll use like the staking module as an example that I always like to use. So you know, staking module delegate, you have all these events, right? Delegate, redelegate, create validator, very standard in Cosmos. And then you have all of these read methods we'll use, just for again an example. And they're pretty simple, right? You know, like get validators, get active validators, you know, get a specific delegation, etc. And we make sure to handle it in a way that is very like Solidity and EVM developer focused, right? So, you know, this is going to be a hex address, something again like we don't really worry about Bec32, we don't really worry about any of that stuff. And then as part of the actual like compilation process of the node, what actually happens is this will get compiled in big air quotes to basically map to an actual precompile itself. So if we open the staking precompile, and there's a bunch of abstractions that are here that are doing it all under the hood as part of the build process, but basically you'll look at this here and it looks very similar, right? Like maybe I should pull them up side by side. It might make a little more sense here. Now that I do this, source Cosmos precompile staking. Back here. So if you look at like staking.go, right, we have like get validator, which we'll use get validator as an example, right? So it takes an argument, which is a common.address. You know, validator helper is just some function that does a bunch of stuff. It doesn't do that much. It's just like data parsing, right? So get active validator, right? Common.address returns a validator type. And then if we go over back to the Solidity interface, right? Get validator, right? Takes an address, returns a validator struct. So basically what it allows you to do is it allows you to write precompiles that kind of like look like contracts, right? Like it's very much familiar typing, right? Like address, return a thing, or like let's use like an example here, right? Like delegate, right? Takes an address, takes an amount, returns a bool. Right? And if we look at delegate here, right? Same thing, right? Takes an address, takes an amount, returns a bool. And we're always kind of iterating on these types of things as well. One of the things that we want to build next is kind of like a stronger type system for like numbers. So right now you can see that like this amount is just a big int, but it would be cool. And one of the things we're kind of scoping is like, how do we make like an actual like UN256 in Go here, and then do things kind of like what the SDK does with like SDK math, right? Like have like a Polaris math library that allows us to do things that kind of like I don't know if you know Soulmate in Solidity land, right? It's like a yeah. Like have like nice like fixed point math libraries around it, and really get the precompile experience as close as possible to writing Solidity, because that's what I would say is like the end goal. And like for instance here, like you see that like context that's passed in, right? One of the first things we've done here, and I can show another example for the precompiles, is we have this. I think it's in here, wherever it is. I'm trying to remember where it is. It's like polar context or something. I'm trying to remember. It's been a while since I've looked at this. Yeah, so here, VM context. So this is what we pass in for the precompile. So every precompile function gets this context, right? The base context is going to be that SDK context, like unwrapping here. But then we also have like nice things that allow for, again, like very simple experience that's familiar to Solidity devs, right? Like message sender is like who the caller was. Message value is how much ether was passed in. Block is like chain.block, right? So we're trying to make it like really, really easy for people who are really experienced with writing Solidity smart contracts to translate that experience by using familiar terminology, familiar kind of code structure, use patterns, etc., and make it easy for them to build precompiles as well.
Yeah, I'm super bullish on precompiles.
Yeah. No, there's some really interesting use cases. Not to plug Scott again, but one of the, like, I absolutely love the way that the guys at Argus are using precompiles. They're not really using them for state in a way, but what they do is they use a precompile that allows them to send over gRPC to all the different shards. So they actually use the precompile as like a gateway, as opposed to it being like, oh, we're like storing state on the actual like Cosmos node. So I think those type of use cases are what, like, personally I'm really excited for, because it allows the EVM to kind of break out of its shell and be like, oh, like I have an EVM, but I want to make a network call. Like now I have the ability to do that because of precompiles, and it, getting that dev experience on the precompiles as good as possible is what allows for those use cases. So that's what I'm super excited about.
First question is about the generated types that those like calling adapters. How are they generated? Like, is this are they generated from like looking into Solidity definition?
Yeah, exactly. So one of the beautiful things that Geth provides us is it provides us this thing called ABI gen, which is a binary that effectively allows for generating these types. So again, as part of this like build process, we generate these like ABI gens. So if we look at like staking module, for instance, we have like a go generate that will automatically go and generate these types. So we have here, right, like Cosmos coin, commission, description, module validator, right, and has all this information that we generate from the Solidity interfaces itself. So the next thing we're kind of doing some work is finding a way to like map the gRPC Cosmos types to these in a really clean way, using like reflection and stuff. So we're getting to the point where getting the dev experience like as clean as possible, and reduce the barrier to entry for people writing precompiles. We think that, my personal opinion is like precompiles, it's not like a race at the bottom in the sense of like who can get the best dev UX, but it also kind of is. I think like if you're a company or a protocol or a chain that needs precompiles for some reason, the solution that you're going to go with is the one that allows you to have the best dev UX and to like fulfill the need. So like, that's why I make sure that our team spends a lot of time playing around with this, testing the dev UX. I have them playing around with like Ava Lab stuff, playing around with OP Stack stuff, and seeing getting feedback, playing with it, see how it feels. Because I think that in our case, right, especially once you get into topics of like cross-chain stuff, I'm not really talking about it today, but like IBC as well. Like if you want a way to like talk over IBC, if you want a way to talk to other chains, getting this precompiled dev UX to the point where you can write like secure, scalable code that is like easy to audit, easy to make sure is secure, but also is able to talk to other chains, make gRPC calls, etc., is going to be really killer.
Another question is, you mentioned networking, so like I'm kind of curious about precompiles, and I know I'm not an expert in precompiles at all. So
Yeah, so that comes down to kind of how, I assume you're using, like, if I'm writing a precompile that, like, makes a network call to, like, some, we'll use Scott again as an example, like a shard or something, like a gRPC call. So that's something where it's kind of, you can do multiple things. If you have a 3-second block time and you have a 30 million gas limit, you could just do the math to figure out, like, oh, if it's a 50 millisecond delay, we should add, whatever the gas would work out to be for that, like that part. Something naive like that would work. Generally, we have just timeouts. So like you say, like, oh, if it takes more than 100 milliseconds or more than 50 milliseconds, then just like kill it and just revert the transaction. Yeah, things like that. So right now, I don't know what the exact limit is right now. There may even not be a limit, but it's something we thought about where because we have that context, we can just have it, you can just set a deadline on it from when it enters the precompile and then just have it abort.
The EVM will receive an error,
Yeah.
and it just like version fails, basically.
Yeah, it's just EVM, the geth type would be EVM execution reverted in all our case.
Okay. Is there some way to like do some sort of cron job? Maybe there's something that can live on the Golang side of things and somehow talk to EVM. Is this possible?
Yeah, so the other thing that, and I believe this is the way the Argus guys do it, but don't hold me to this, I'd have to ask Scott, is that you can basically have it so the precompile triggers the job, but it makes the network call asynchronously. So you could make it so the precompile is gonna, like, when you call it, it fires off the job, but it doesn't return anything. It's just like, oh, like, return bool success, job activated, and then another transaction later can go back and like pull the result. Much like how, chain links like VRF works, for instance, right? Where you have to like make the one call, wait for it to come back, and then get it. Something like that, I think, is from a developer perspective, or like if you're a builder perspective, probably the way to architect that, just so that you know that it's, you don't have to worry about it stalling or causing a transaction to fail for some reason. Yeah, no worries.
Does Parachain have its own validators? And if so, what are the advantages of using Celestia versus keeping everything within the Parachain, Cosmos chain?
So right now, Bearchain's a full all-one, so we're not actually using Celestia for DA right now. But what we want to do is for Polaris, we want Polaris to get on as many chains as possible. And part of that is making sure that it's compatible with frameworks like Rollkit. And we see kind of Celestia as a really good partner in that regard to make sure that people who are building EVM chains don't necessarily have to worry about bootstrapping a validator set, because it is a difficult thing to do, right? It's not easy, especially if you want to build applications that are scaling to millions of dollars. It's a responsibility to make sure that your validator set is good. So if you can offload that security while also getting the benefits of the NMT and the DA layer, then it's 100% worth it in a lot of use cases.
Yeah, you can also like we showed in the video and the slides, like if you can deploy an OP stack rollup on top of Polaris, that means that you should be able to in the future deploy rollups on top of Bearchain, right? So then you could use Bearchain as a settlement layer, which I think comes with like multiple advantages given the way the like liquid staking. Sorry, not liquid staking, proof of liquidity stuff works. Because ultimately, as a rollup, like one of the main reasons you want to have a validating bridge is to essentially gain access to the like liquidity of the underlying like layer, right? So yeah.
Polaris has a fee market in the EVM, but the Cosmos side doesn't.
Yeah.
How does it work exactly?
So how it works basically is for exactly that. So the fee market exists in the EVM. Right now we just use it's the geth EIP 1559 code. Like it's literally just part of the block generation process. We're just like, okay, what's the parent hash or what's the parent header? And then just run the simple PI controller, PD controller, I can't remember what it is. Yeah, so there's nothing really, really fancy in that regard. We have a thesis that like the more code we can borrow from geth and the execution client side, the better. And I'm giving a talk later today about how we want to move to a model that's like fully kind of execution client, consensus client, and utilizing kind of the Cosmos side for more just for consensus and precompiles and stuff, while using like a fully minimal fork of geth or Aragon or Reth or whatever, just to minimize dependencies and make it kind of if you want to build some crazy Cosmos thing, you don't have to worry about that like breaking the EVM and kind of vice versa.
And otherwise, what is the alternative? You write like fee market code in the Cosmos SDK, and then you have to hook it up to the EVM, and then it starts getting very messy very quick, right?
Yeah, the big thing with Polaris is we wanted to like simplicity first. So there's definitely some things that are really opinionated in the way we do things, because of the fact that we want to try to like minimize complexity, because we see that as like a big part of why a lot of these EVM frameworks end up not being EVM equivalent or have problems, just because they're kind of spaghetti code and don't have clean dependency paths in architecture, et cetera. None, no, never. I would never name a Cosmos EVM framework that's full of spaghetti code and has problems. Never. I would never do that team like that. Exactly.
They know who they are.
Yeah, they know. They know, it's okay. We love them for providing inspiration to build this. Oh, you're doing that. I thought you were
Yeah,
going to
no.
ask a question, Josh.
All right.
Awesome. One more at the back.
Yeah, I had a question about how the N2 blocks, how the state is processed. Is it a sovereign chain or is it like the OP stack where the N2 chain is derived thanks to the settlement layer blocks?
For which piece exactly? Like the.
For this design, where we're using this design, where the settlement layer is the Polaris Cosmos chain. How the N2 blocks are processed? Is it done thanks to the settlement layer or it is sovereign like the full nodes of this design can decide what is the consensus and how the state is processed?
This is probably a Diego question.
Yeah, I mean, so the Polaris Cosmos as a gate chain is, you can just think about it as a sovereign rollup that's running Polaris, right? So it's like an EVM rollup. And because Polaris is good and it's really good at essentially being Geth, it almost acts like a pure EVM rollup at that. It's almost like if you took Geth and just made it a rollup. It's almost like a very similar philosophy to what the folks at OP Labs have, right? The OP Stack chain essentially works in the same way that an OP Stack chain settled on Ethereum would work, right? Like ultimately the ordering of the blocks and all that stuff is down to like the sequencer for the OP Stack chain, and then stuff gets posted to Polaris, and in this case, in our diagram, right, like, and for the video that we showed, the DA gets posted to Celestia, but that doesn't have to be the case. You could build like a pure, like vanilla OP Stack rollup on top of Polaris using Rollkit, or on top of Polaris on Verachain, right? Like, I hope that like answers the question. Like, there's nothing different in this setup that you would see somewhere else. It's almost like you could almost like cover the Celestia part, and I can just tell you that that is like Ethereum, and that's optimism, right?
It's all like this diagram that we've built is just like one. There's hundreds of literally infinite ways to glue this all together, right?
Yeah.
This is just one we chose where we thought it was kind of an interesting use case that shows off kind of the work that these guys have done with OP, and then also Rollkit, us, etc. So we thought it was kind of comprehensive in that regard.
Yeah, there's many ways to put a set of Legos together, I guess.
Sweet, awesome. Thank you everyone for coming. I hope not only it was good for Rollkit stuff, but also precompiles. If you guys have any questions about precompiles, come grab me after this as well. I'd love to chat about it.
Thank you.